Welcome to my second lecture series. So today we are going to say about the need of additive manufacturing method in the modern industry. Okay. So in the earlier class we just have a discussion regarding what is meant by additive manufacturing and what are the parts which can be manufactured and the year of history that how the additive manufacturing has been evolved. So regarding with this, what kind of shapes that we can manufacture, in all this way we have come across with the examples in my earlier session. But in this session we just need to know why we need to go for additive manufacturing. That is the important thing. So generally we know that for any manufacturing, the rising demands, the rising need for the customized products is day by day it has been increased. And also the customers looking for the shorter product life cycles and also cost effective low volume production they are looking for. And majority of the application nowadays we are preferring the lightweight and the complex designs. Here some of the images which I shown for your understanding purpose. These components like silencer pad, and there is a bumper, and there is an other than the silencer pad we are used to manufacture the carburetor, and also there is a crankcase. So for all this lightweight application it can be done by through the additive manufacturing with the cost effective one, and it does not take much time as like a conventional manufacturing method. And even though the shapes are having a different kind of shapes, and even though it having a different complicated shapes, it cannot take much time as like in conventional manufacturing. Hence it is an customized product. That is why it is called it as a customized product. And their applications also, it can be preferably we need to use it for lightweight, and the complex designs has been done depends on the requirement of the customers. Okay. And how can we empathize, for example, the product development cycle, how the design can be manufactured as a product. Here there is a flow chart which you have seen in this screen. The first one, we can able to generating a model and the correction and the CAD correction of the model which you can see in the desktop. Following that, once the design has been done by using any kind of software like Solid Edge, SolidWorks, or Creo, even whatever the software design modeling software is available, we can use any kind of designs to make the component, and that software CAD has been converted into STL format, which means standard readable format. That STL is nothing but it can able to read the shape and recognize the points of the shape, so that it can able to execute in the production. Okay, so first of all generating a model and implementing the CAD corrections. Following that, this CAD can be converted into the STL format, and from the STL format the third process it can start generating the slicing, which means you can read the layer by layer of manufacturing of the particular shape. That slicing is separate. By using the separate software we can able to do the slicing one, and based upon that we can generating the G code. So once the slicing is done and G code has been generated, and following that the simulation of G code has been done. From the slicing and the generation, it can able to take it as a simulation of G code. From the simulation it can able to convert it to simulate a 3D printing in the CAD/CAM environment. From the simulation of G code, the next stages which can be attained, that is simulation of 3D printing in CAD/CAM environment, and following that the prototype will start doing the work. That printer has start operated, and so that the layer by layer manufacturing has been begins. Once the manufacturing is begin, then finally after a certain period of time the final output product which we can able to get. Okay, that is what you call the 3D printer model. Okay, so based upon that we can able to manufacturing this way, that is generating a model and the CAD correction of the model, following that STL convert, following that slicing and generation of the G code, following that simulation of the G code, and simulation of 3D printing in CAD CAM environment. And here the next one, it is coming under the category of complex management defined. Complexity management means generally we having so many solely different shapes are there, solely different designs will be available, and the traditional manufacturing limits can exceeding the complex geometries. That AM supports the lattices. It can be either, it may be any kind of cubical shapes or any kind of lattices. It can able to make it the shape in generation, and according to the internal channels, it can enable the multi-material integration. So once the material has been loaded, that material will start by throwing the filament winding process, it can be done, and that filament winding will start support the cell by cell, so that there is a improvement in functional performance has been noticed. That functional performance can be executed in the modern manufacturing according to the type of machines. So that is why we need to prefer the complexity management while we going for the additive manufacturing process. And following that, we need to prefer for the sustainability. Sustainability means we know that it is a minimum material waste, where this minimum material has been taken according to the recyclable materials and the energy efficient materials for the subtractive methods. Okay, so remaining we will continue in the next session. Thank you.